Welcome to this online class. I'm Barnabas Mogo, and I hope each one of you knows me. We are going to have this online class for some days to come, and then from there we shall be having the face-to-face class. I will make sure that's available for you, especially during the calculation of mathematics that are pertaining to this course, and also in other assessments. So I will be present, and there is no point of worry. So when we are discussing about the structural design, the whole issue about structural design is to be able to design the structure as the way it is. That is, we can be able to tell about the dimensions of the beam, the column, the slab, the struts, the slab, and also the footing. So when we are discussing about the structural design, the whole issue is the matter to do with the calculation of the dimensions and also calculation of the weights and also the stresses that are experienced by any structure. So this course is a weighted course, but then it will be subdivided into two main parts. That is the design of the reinforcement concrete and also the design of the steel parts. But from experience, we have never been able to cover the design of the concrete parts. But we have been able to cover the design of reinforcement of concrete. So I'm sure that even in this time round, we are only going to use we are only going to design the concrete part. When we are designing, we are going to use a code that is BS8110, which is the code of practice. And when we are looking at the code of practice, we are looking at the issue to do with the standard way of designing, something that has been agreed countrywide or worldwide for us to be able to use in the design. So before I go to that, I'm going to go through the course outline that we are only going to measure on. One of them is that we are going to introduce the units as it was done by the online class, that is across the campuses. And one of the issues that we're going to deal with is the conceptual design. That is the design of then to conceptualize or to have that concept pertaining to the design aspects. We're also going to look at the preliminary design, that is the initial design. That is, we are going to need to know what are the parameters that are required when you want to design. The third thing that we are going to look at is the design detail, that is the detailed design, whereby we are going to calculate the force, we are going to calculate the weight, we are going to calculate the dimensions, we are also going to calculate the stress and the number of the bars that are required in the design. One thing I want you to know is that we have a difference between the plain concrete and also the reinforcement concrete. The plain concrete is the one that without the reinforcement bars, but in the reinforcement concrete, we have the reinforcement bars. Then we are also going to look at the standard, that is, we are also going to look at the design standards, that is the one that I have just talked about, the design, the British Standard Code of Practice. It is BS8110. Then we are also going to look at the structural elements. So we look at the beam, the column, the slab, and the footing. Those are four main structural elements that we are going to deal with. Then the second thing that we need to know is about the properties of the concrete. When we're looking at the properties of the concrete, we are looking at the one thing that we need to know is that concrete is made up of the cement, the sand, and also the ballast in their respective ratios or in their ratios. And the ratio of the concrete is the one that is going to determine the strength of that concrete. One thing that you need to know about the strength of the concrete is that it is going to be given the value of FCU, as we are going to see later. So in this one, we are going to look at the specification of materials in concrete and steel. We are going to look at another properties, that is durability, the crit, the modular relationship, the modular ratio, the stress-strain relationship, and also the Poisson's ratio. Then our third topic will be the limit state design. And when we are looking at the limit state design, we are going to look at the introduction to limit state design. That is, we are going to know that there is two types of design. One is the serviceability limit state, and the other one is the ultimate limit states. We are going to look at each one of them. So, and when we are doing that, we are also going to look at the characteristic material strength. That is, we are going to see that we have the design of concrete is going to be FCU, meaning that it is the characteristic strength of concrete. Then we are also going to have FY, which is the characteristic strength of steel or reinforcement material. Then we are going to look at the characteristic load. When we're looking at the characteristic load, we are looking at the parameters. We are looking at those parameters that are going to be used in the design. That is, the characteristic load is, for example, we have the factored load and we have the unfactored load. So we are going to look at the factored section of the reinforcement concrete. We're also going to look at the factored section of the reinforcement concrete. We are going to see it later. Then we are also going to look at the analysis of the structure. Analysis of the structure, that is, we are going to see the combination of the load, the type of the load that are in the structure, the live load, the dead load. We are also going to look at the analysis of a loaded beam. Then the analysis and beam section. We are going to look at how you can be able to analyze the beam. In one, we are going to see that we have two main types of the beam when we are designing. One of them is single reinforcement beam, and then we have the double reinforcement beam. We are going to look at each of the case when we get to that point. Then we are also going to look at the design of rectangular beam section and the T beam section. In this case, we are going to look at how you can be able to design a rectangular beam. That is the one that we are going to concentrate on. That is single and also double reinforcement rectangular beam and also T-section. We are going to look at each of the case, and we are going to look at how you can be able to reinforce either the tension reinforcement, compression reinforcement, and also shear reinforcement. We are going to look at the movement, the momentum, and we are going to look at how you can be able to calculate the number of bars. You can be able to calculate the number of the rings, that is the one that are joining the bars, and we are going to see how you can be able to use the S8110 for you to be able to carry out that assignment. Then we are also going to look at the design of reinforcement slab, and we are going to see that we have two main types of the slab: one-way slab and also two-way slab. Then we are going to look at how you can be able to reinforce that slab. We are also going to look at the design of reinforced concrete columns. When we are looking at the columns, we are going to see that we have two main types of column. We have the short column and we have the long column or the slender column. We are going to see how you can be able to load the column either axially or eccentrically. We are going to see that when we are loading axially, we are loading the column at perpendicular points. But when we are loading, that is the center point, then we are going to see the eccentric point of loading. That is, we have concentric and eccentric. Concentric is at the center, while the eccentric is at the other another point which is not at the center. Then we are going to look at the design of reinforced concrete foundation. That is, we are going to see the introduction and definition of the terms. We are going to look at the isolated or the pad footing, and we are going to look at the strip footing. This is just what we are going to measure on in this unit. This is exactly what we shall do pertaining to this unit. This information, you can also get it from the course Mundo, and you can also use these as your reference. You can refer that information from the information of this unit from that from those reference materials. Okay, when we're looking at the introduction, I'm just going to give you the recap, or we are just going to give you the concept pertaining to the unit in the introduction to the design aspects. And we are going to see that when we are doing this, we need to first of all conceptualize what the design in this case pertains to. We are going to see that in this case, we need to have the understanding pertaining to the requirement by the client and the design beliefs. That is, you need to know what the client requires when you are designing his or her building. Then we are going to see that you need to have the specification pertaining to the requirements that are associated with the site. That is, you need to know about the site condition. For example, if it is muddy, if it is locky, if that is, you have the information pertaining to the site that you want to design. That is, you want to put up your building. Then the next thing that you need to know is identification of relevant code and regulation pertaining to that area. For example, in Kenya, we have different codes of practice when we are doing the design and also the construction. For example, the National Construction Authority requires you to be able to do ABCD. You need to know all these codes when you are designing. Then you need to evaluate the stability both for construction and also for the surface. And that is, you need to know how stable is the construction site, how stable is the area that you are dealing with. Then you need to know how to taking into account the input by the profession. That is, you need to know that it's not only the engineers who are required during the construction and the design aspects of the building. One of them, the other people that we require is like the architect. We require the geotechnical engineering. We require the surface engineering. We require the surface controls people. Those are some of the other people that must come to play when you are doing any construction. Then you need to identify the alternatives of layout. So that you can be able to come up with different ways of weighing the alternative. That is, you can be able to weigh the alternative so that you can be able to carry out your construction effectively. Then we need to know about the preliminary design aspects. When we are looking at the preliminary design aspects, you need to know how to carry out a simple and approximate hard calculations to assess the variability of ledges of alternatives that are there in the conceptual solutions. This is normally done either manually or by the help of the computer. That is, you need to know, although you have the concept pertaining to the design, you need to know the preliminary design. That is, you can be able to calculate if just preliminary, just merely, you can be able to calculate the design aspects of any building. That is, you don't require a lot of information for you to be able to design, just calculate it merely. Then from there, you need to know how to come up with the design, the detailed design, that is the actual design of the building. Like that is, for example, you need to have the idealization of the structure into load bearing frames and elements for analysis and the design. Then you need to know how to estimate the loading, that is the live load and also the dead load. You also need to know that the analysis to determine the maximum moment and the thrust. That is the moment. We know that the moment is distance times the perpendicular, that is the force times perpendicular distance from the point of action. You need to know the thrust, the force, the shear, the tension, all those things that you need to know. You need to know how to analyze them. Then from there, you need to know how the design of sections, the design of section and reinforcement arrangement for the slab, the beam, that is the way they are going to be alleged. You need to know how to connect the points, that is the beam, the slab, the footing, and the column. You need to know each of the case. Then from there, you need the production of arrangement and detailed design, whereby you are going to know how, which bar or how many, the number of bars that are going to be involved in the beam, in the column, in the slab, in the footing. You need to know each of the case. Then from there, you need design standards. When we're looking at the design standards, I told you that you need to know about the BS 8110. When we are looking at the BS 8110, this is the code of practice that we are going to use in this design. But we have the European codes, which is the current type of the code that are used in the design. But in this case, in this unit, we are going to use BS 8110 in order for us to refer each and every aspect of the design in that reference manual. This is just a reference manual, the manual that is going to be used in our design. So you need to download this book, or I'm going to share with you so that you can be able to print it. And this is the only course that you are supposed to use this reference material in your examination. Then we also need to look at the structural elements. Remember, when we are looking at the structural mechanics, one, we looked at the beam, the slab, the column, the walling, and the basis of the footing. You need to check you need to revise. You need to know how to revise, or you need to revise this information so that you can understand the beam, that is, it's a horizontal member that is carrying the lateral loads. You need to know about the slab, the first floor, the second floor, the third floor. Those are the slabs. When we are talking about the floor is the slab. So it's a horizontal plate element carrying the lateral load. You need to know about the column. Remember, we see that those are the vertical elements of the structure that are carrying with the weight from the slab. So they are vertical member of the structure. Then we need to know about the wall. The wall, everybody knows about the wall. Then the footing or the foundation, this is the structural member that are anchored to the ground so that it can dispatch all the weight. So they are connected in such that you have the beam that is carrying the slab, and then the slab, the weight from the beam in the slab, they are transferred by the column. Then from there, they are transferred to the ground or to the base or to the footing. Then from the footing, all the weight are dispatched to the ground. That is what we said in structural mechanics 1 and structural mechanics 2. So that is just the introduction of what we need to know, or what we need to understand about the whole concept about the unit. Then the second topic that we need to discuss, or to be able to know about, is the topic pertaining to the properties of concrete. I told you that concrete is made up of 3 main items or quantities. One of them is the ballast or cotton or aggregates. We have the fine aggregates and we have the coarse aggregates. We also have the sand, the sandy part. We have the cement parts, and then they cannot be able to combine without the presence of water. So when we have water, it is the one that is going to be used to mix that ratio for us to be able to have the wet concrete. So we have the dry concrete and we have the wet concrete. So the dry mix is made up of cement, sand, and ballast. But when we mix with water, that is called the wet concrete. So when you are looking at the reinforcement concrete, you also add something that is called the reinforcement material. In this case, the reinforcement bars, tumors. So when we are looking at these Y8, Y10, Y12, those are the reinforcement bars. Those are reinforcement materials. So when we have the reinforcement concrete, is a composite material that is made of steel. That is the cement, sand, ballast, and that is cement, sand, and ballast. Then you mix with the reinforcement bars. Then from there you mix with the water. That is when they mix the wet concrete. You mix with the reinforcement material that is called the reinforcement concrete. Then we have the plain concrete that is does not have any reinforcement bars. So we are going to look at the reinforcement concrete. It is a compound material because it has the concrete part and it has the reinforcement part. So the reinforcement concrete is made up of the reinforcement material and also the concrete material. The combination of the two is going to form the composite or compound material. So we are going to see that it is of the concrete is of different. It inhibits different specifications. When it is inhibiting this different specification, we are going to see that concrete is it has different classes, or concrete has different classes depending on the type of the mix. So for example, if you have 148, that is the first column, concrete mix, we have the grade and we have the cube strength. Cube strength is FCU, the strength of the concrete. In this unit, it is going to be ablated by FCU. So you have a concrete mix of 148, meaning that 1 part of the cement, 4 part of the sand, and 8 part of the ballast. So this one is given code that is C10. C10, meaning that it have FCU of 10 Newton per millimeter squared. The strength of that concrete is 10 Newton per millimeter squared. So we have the concrete mix of 1:4:8. That is grade 10. Grade 10, it has FCU. The cube strength of the characteristic strength of concrete is 10 Newton per millimeter squared. When we have 1:3:6, it means that we have 1 part of the cement, 3 parts of the sand, and 6 parts of the ballast. So this one have the class of C15. It means that it's the FCU, the strength of that concrete is 15 Newton per millimeter squared. 15 Newton per millimeter squared. Then we have 1:2:4 mix of the concrete. It means that it is C20, the grade of that concrete is C20, and that means that the FCU, the characteristic strength of that concrete is 20 Newton per millimeter squared. Likewise, we have 1, 1.5, and 3 concrete mix. It means that it is C25. The strength that is FCU is equals to 25 Newton per millimeter squared. That is just what it means. So depending on the type of the mix that is in that concrete, then we can have different strength. So depending on the strength of the concrete, you get its respective characteristic strength. So we are going to be saying that FCU of 20, FCU of 15, FCU of 25, FCU of 10. That means that it's the characteristic strength of concrete, and it is dependent on the concrete mix. Then from there, we need to know that C10 is used. That is C10, the characteristic strength, that is FCU of 10 is the binding concrete. 15 is the ground footing. 20 and 25 can be used for the structural concrete. And also FCU is going to stand for characteristic strength of concrete. We also have the characteristic strength of the steel. The characteristic strength of the steel is going to be given by Fy, as you can see from that table. And this Fy, it can be either 250 Newton per millimeter squared, or it can be 460 Newton per millimeter squared. This is dependent on the way that reinforcement material has been prepared. For example, the hot rolled mild steel, it have Fy of 250 Newton per millimeter squared. That is, the characteristic strength of reinforcement is 250 Newton per millimeter squared. But when we have hot rolled high yield steel, it has the characteristic strength Fy of 460 Newton per millimeter squared. So that is the only difference. So depending on the way it has been prepared, you can have two reinforcement. That is the characteristic design strength of steel, either 250 or 460 Newton per millimeter square. Then we need to know also about the durability part of the concrete. When we are looking at the durability part of the concrete, we need to know about that is the concrete is very durable. That's something that we need to know. But for it to be durable, it must have some other aspect, like the way it has been mixed, the curing aspects, and the condition of that area, and other aspects. So the durability is influenced by the exposure condition, the way that concrete has been exposed, the concrete quality, the quality of that concrete, the strength or the cover of the reinforcement. We are going to see that we have the reinforcement cover. That reinforcement cover is the cover that has been put on top, so that the reinforcement material cannot be seen. Also, we are going to see that the width of any crack influences the cracking. These are just notes. Then we are going to look at the creep, which is the continuous deformation of member under sustained load. It is the phenomenon that is associated with many materials, but this is particular evidence with concrete. So we are going to see that the deformation of the material, the deformation of the concrete, is the one that governs its creep. And that's one you can just learn. It's not something that is so difficult. Then shrinkage and thermal movement is also another characteristic of strength that is of concrete that we are going to look at. That is the shrinkability of the concrete, and then the thermal movement, meaning that it is going to experience the change in the temperature. You can just read this notes, and no one is going to ask you a lot of information, but you can just read it for your online classes, or for your online understanding, or for your online CAT, but not in the main exam. Then we are going to look at the stress strength relationship. You know that the strength is the force of a cross-sectional area. The strain is the percentage of elongation of any material, and you are going to see that this one is the one that determines something that is called the loading. It is the one that is going to determine what is it called? The stress, the strain relationship is going to determine the characteristic part of the concrete. So in this case, this is exactly what we are supposed to look at, and we are going to see that you can measure on different aspects of the concrete. I'm going to stop sharing this so that I can share another one. I'm going to share another item. Just a minute. I want to share another. Just a minute. I want to share another document. I want to share another document. Yes, here it is. I'm just sharing in a minute. Just going to share. I'm sharing another. Yes, here it is. This is the third topic that you need to understand, or you need to just have the preliminary before we go to the detailed design. In the examination, don't expect a lot of theory pertaining to this one. Just expect that we are going to tackle the practical part of the notes. So the limited state design. When we're looking at the limited state design, we are looking at the design of the actual member. That is, we have the serviceability limit states, and we have the ultimate limit state. So introduction to limited state design, aims and method of design. We are going to see that we have the clause in the BS8110, which is 2.11 code of states. It states that the aim of the design is to achieve an acceptable probability that the structure will perform satisfactorily during its life. And therefore, for any structure to be able to achieve an acceptable probability for it to be used during its lifespan, it needs to have the following parameter. One, it must be able to carry out the load safely. It must, or it should not deform excessively, and it should have adequate stability and durability and resistance to the effect of misuse and fire. Meaning that for us to have for us to be able to have any structure that is carrying the weight effectively, it should be able, one, to be able to be safe against any load that is going to be applied on it, be it life load or dead load. It should be able to perform effectively, even without excessive deformation. It should not deform excessively for it not to be obsolete for use. It should also be durable during its lifespan. It should be able to resist the effect of fire, of misuse, in any other calamity that is exposed into. Then the same structure on when we are using the limited state design code of practice, it states that the method recommended in the code is limited state design, where account is taken for the theory, the experiment, and also the experience. You need to have the theoretical part for you to be able to use this method. You need to have the experimental area, and you also, that is when you are, for example, when you are crashing the cube, in order for you to determine the strength of that cube, you also need to know the experience, or you need to have the experience so that you can be able to do it. So the criteria for the safe design, you need to have the limited state design. That one we are going to look at it. You can just have the grasp of by reading the notes. That is, the whole structure or its elements should not collapse, overturn, or buckle when subjected to the design load. Meaning that the structure should be safe against any overturning, any collapse, or any buckling. The structure itself should be safe. Then from there, you need to know that serviceability limit states it is for you are just designing for the comfortability of the structure or the object or people that are going to be in that structure. For example, you are designing the structure should not become unfit. That is what we are saying about serviceability limit state. It should not become unfit to use due to the excessive deflection, due to excessive cracking, due to excessive fibrillation. That is, whoever is occupying that structure, be it water, be it people, it should be comfortable. It should be comfort. There is comfortability aspect that are coming with it. Sure. So it should not be excessive from deformation. That is a deflection. The structure should not, although it is not overturning or collapsing, it should not have a lot of cracks. Although it is not buckling, it should not have a lot of fibrillation. So it's not only the ultimate limit state that we're supposed to look at. We are also supposed to look at serviceability limit state, whereby we are determining or we are coming up with the serviceability limit state. We are coming up with the comfortability aspects of those things that are occupying that structure. So in the ultimate limit state design, you need to know about the strength, that is the stability and the robustness of that structure. The strength, the structure should the loading in that structure, it must be designed to carry the most severe combination of the loading. That is what you need to know. That when you are designing in the structure, when you are designing the structure, it should be able to carry the combination of the loading, the design aspect of the loading, to carry the most severe combination of the loading. That is the dead load and the life load. The most severe, meaning that the worst case scenario, it should be carried by this, should be designed to carry by use of the light strength. So we are going to look at it, at that one. Then we are going to look at the stability. How stable is that structure? Is either in terms of the layout. That is the layout. The layout should be such that it gives a stable and robust structure. Then we are going to look at the robustness and also the serviceability limit states. When we say that we have the ultimate limit states, we have the serviceability limit states. And when we are looking at the serviceability limit states, we are going to be looking at deflection aspects, as we are going to see during our actual design. We are going to look at the cracking, and also we are going to look at other aspects pertaining to the fire and the like. So I wanted us to have the preliminary information pertaining to the design, so that when we come up with the actual design, we are going to be able to understand fully whatever we are supposed to discuss. This was the first video that I wanted to share with you, and then I'm going to have another video, the continuation of this one, so that you can be able to understand fully. Thank you. If you have any other question, I will be able to answer later.